All right, guys, today we're looking at an investigation. So you're going to do another experiment for me at home based on this PowerPoint here today, okay? It should be a little bit of fun. It might be a little bit messy though, so um, just make sure you have a nice clean environment for it, okay? And keep the mess to a minimum. What we're looking at is investigating the effect of a meteor's height above, we'll say, sea level on the diameter of a crater. So really, this is kind of like a modeling what would happen if a meteor passed through our own atmosphere, Earth's atmosphere, and it hit the surface of the planet. Okay, so that's the goal here. You can see there's a picture here of a setup. I'll be showing a few more pictures of this. What you'll need for this really are a few basic things like you could get a lunchbox. Okay, you could fill that lunchbox with flour. So you'll need flour for this as well. So any type of flour will be fine. You'll need some sort of bowl or object to mimic what the meteor would look like. Okay, and you just need measuring instruments then, like a ruler, and you want to have pencils and stuff to record your results. Okay, so for this, before you start, really, you should be able to do a few of these matching activities. So if we look here at this, for example, you have to match the definition with the word. Okay, so like if I look here, for example, F, a ball of gas that releases heat and light due to nuclear explosions, which would be the best match for that? Well, a meteor doesn't give out heat and light. Okay, so and due to nuclear explosions, it definitely wouldn't be that, or that. It is a star. Okay, so a star matches here with this definition here. Okay, so the best way to do this, and by the way, is practice for your exam that's going to be coming up at the end of the year. Astronomy is a big feature, a big aspect of your exam. Okay, that's the only hint I'll give you. So basically, match those. They're three matches with F. Okay, and finish off those. Now, so the main goals here, what are we hoping to achieve by all of this? We're hoping to be able to figure out what relationship the actual meteor's elevation above sea level, or its height, has on the diameter of a crater. So if it's higher, does it make the crater bigger? Okay, or does it have any effect at all? We then want to talk about accurate measurements of length. Okay, how do we take proper measurements of length? And now this mightn't be possible at home, but certainly we'll be able to calculate the mass of the meteor that you're measuring. You probably won't be able to work out. Well, we'll see. It depends on what you have. So this is the setup. Okay, effectively what you're doing is you're dropping a ball into flour and you're looking at the crater that it was created. Okay. You want to have a nicely sized lunchbox or container. I'm sure you'll find something at home, just like a cardboard box would work fine as well. And you're going to drop the ball from different heights. Okay, so this is the setup. What you're going to do is you're going to pour flour into a tray or a lunchbox or a box or anything that is suitable at home to about a depth of about 5 centimeters. So you're going to have a ruler that you're going to measure this out. You're going to then make sure that the flour has been smoothed out. Okay, so we're pretending there's no craters here on the surface to begin with. So this is the smoothed out surface. You're then going to try to measure the mass. Now, if this may or may not be possible at home, if you have a weighing scales for baking or whatever, technically what that's measuring there is actually the mass of the flour. So what you could do is you could put the ball on the weighing scales and get a reading for it. And then what you do to figure out its weight is you multiply by 10. So the force of gravity by the mass, which is 10. And you get a value then for its weight. Okay, so mass and weight are different, and we will see that in a second here. Mass is the amount of matter that something contains in grams. Okay, and weight is the force of gravity acting on an object, so it's measured in something called newtons. So if you can do steps 3 and 4, then move on straight away onto this step here. Okay, what you're to do then is you're to release the meteor from 3 different heights over the flour tray. So Like for example, here I've made sure that this ball will roll out of this tube rather than just dropping it, because I don't want to accelerate the ball myself. I want it to fall naturally at its own speed. Okay, so that I won't just throw it down and that'll affect it. Okay, so I want a fair experiment. So you choose three different heights yourself. Now I suggest the bigger the height, the better. Okay, so if you want to drop it like from, we'll say a few steps up, we'll say maybe on a stairs or something, that'd be better than if you have smaller heights, you probably won't see like a big difference in your results. And then what you're going to do is you're going to carefully remove the ball, okay, with minimal damage to the meteor, so that you can measure the diameter of this crater. The diameter, remember, is something that we use as a measurement of circles. It's basically the length across of the circle. Okay, so the full length across. So that's what we're measuring here, the full length across of this circle that's created as a result of the meteor. We're not concerned about depth of the meteor, so we don't really care about how deep it gets, but we do care about the diameter, and you record your results. So you will have three results that correspond. You will have a result like this, okay? You will have height measured out in meters, ideally. So like if you're measuring out, you could use, if you have any like measuring instruments at home, like for example measuring tape, then that would be great. Okay, and you're measuring out your heights here, so 0.25, 0.5, 0.75, 1 meter. Okay, these are examples. You can take any heights that you prefer yourself, that suit yourself. Okay, and then you're just looking at the diameter of the crater that corresponds with this. What you're going to do then is you're going to try and draw a graph. Okay, so on this axis here, this is the x-axis and this is the y-axis. So on this axis here, what you're going to do is you're going to write down the heights. So heights are going to be on this axis here. So you'll go across in even amounts. So like for example, we have 1, 2, 3, 4, 5, that'll be 0.85. 1, 2, 3, 4, 5, that'll be 5, and so on there across. Then you will decide on your diameter, and the diameter is going to be represented here on this axis. Okay, now for this, yeah, for this we'll just work with bar graphs. It'll be just very simply bar graphs will be perfect for this. Okay, the mass of the meteor then is the measurement of the ball that you got, and the weight then is worked out multiplying that value by 10. Okay, so then you should get a value and you should be able to answer these questions. Okay, parts A to F. So your work today is going to be as follows. I want you to do the experiment, and I want to see that this experiment is written up in full. Remember, I gave you a sample experiment right up at the start of the year. Okay, that would have included, and I'll go back to it here. That would have included a title and date. So the title for this experiment I gave you already, which is to investigate the effect of height on the diameter of a crater. The date is today's date, so what is it? 6th of May. You write down the apparatus that you yourself used, and then you write down the method as bullet points. Okay. Once the bullet points are written down, you draw a diagram which is labeled of your setup. You then write down your results, and you try to draw the graph that I described to you there. You didn't come up with your conclusion. Okay, your conclusion is, having done the experiment, what does this tell me based on my results? Okay, and once you've done all that, then you come back to these questions and you answer these questions after the experiment write-up. Okay, because it's a good bit of work there, I'm going to say that's the work for today and tomorrow, and I'll be back on to you next week. Okay, so that's it for today. We'll talk to you later.